Let's talk a minute about quantum numbers. First, I know that this seems very confusing, but it will make more sense the more you work at it. First, let's talk about the quantum model. It's the current model for the atom. The Bohr model was a two-dimensional model with one quantum number, the energy level. And if you picture those Bohr models, they're two-dimensional. They're on a flat piece of paper. But then there were two new things that came about that told us we needed to change it. First was the Heisenberg uncertainty principle. And this principle states that we cannot know both the velocity and the position of an electron. And the reason is because if we're measuring one, we're changing the other. Also, a scientist by the name of Schrödinger came up with a wave equation. And this treats the electrons and atoms as waves. And it allows you to mathematically solve for these quantum numbers we're going to talk about. These quantum numbers allow you to create a three-dimensional model. So not just up and down, but into the page. We also, because we don't know exactly where the electrons are, can't say they're in a nice perfect ring. Instead, we make a probability cloud, a three-dimensional shape, where there's a 90% chance that the electron is. The first three quantum numbers describe the orbital that the electron's in. And the last quantum number describes the electron's spin. The first quantum number is called the principal quantum number, and it's represented by the letter N. This quantum number is the one that the Bohr model had. It describes the energy level. And N can be equal to anything between 1 and 7. You can look at an element on the periodic table and tell how many energy levels it'll have because it's equal to the element's period number. So oxygen is in the second period and will have 2 energy levels. The second quantum number is called the angular momentum quantum number and is represented with a lowercase l. This describes the shape of the orbital. There are 4 different orbital shapes, S, P, D, and F. And I have a few terms. They're not official terms, but they're terms that might help you remember what those shapes look like. The S orbital is a sphere, like this red one here. The P orbital is a peanut, like the blue. And the D orbital is double peanut, like the green one. The F orbital, some of them look like flowers, some of them don't. You'll see all the different F orbitals in a few minutes. We won't use that one nearly as much, but I would expect you to recognize S, P, and D by sight. The third quantum number is the magnetic quantum number, and it's represented with the lowercase m. And it describes the orientation of the orbital. Remember, we're talking about three-dimensional space. So you can turn, remember that peanut shape? You can turn that in 3 different ways. And that is 3 different orientations. It's important to know that the S orbital has one orientation. It's a sphere. No matter how you turn that, it's going to look exactly the same. P has 3 orientations, D has 5, and F has 7. This is an example of the S orbital. You can see that on these orbitals, I've drawn the 3 axes, X, Y, and Z. X is going in and out of the page. And you can see this is an example of 1s and 2s. So the first energy level, S orbital, and the second energy level, S orbital. The only difference is that the second energy level, S orbital, is larger. These pictures show you the P orbital. The yellow one is px, that means it's oriented on the x-axis. The blue is py, and the red is pz. And you can see that we're just turning that shape in a different direction. You might also notice in the bottom right hand, if you stack all 3 up, they take the same amount of space as a sphere, approximately. And here you can see the 5 orientations of the d orbital. It's turned different directions. The only one that looks odd is the very last one, but that's what the mathematics solve for. Most of the other ones you'll be able to recognize. And these show the 7 f orbitals. These get a little bit different, but the bottom four, you can see, they look sort of like flowers. So hopefully that will help you remember what shape those are. The last quantum number is the spin quantum number. It's represented with S. And it describes the direction an electron is spinning in. And it can either be positive 1/2 for spin up or negative 1/2 for spin down. And the reason it can only be these two ways is when an electron spins, it creates a magnet. And they have a north and a south pole. And 2 electrons are always in every orbital. They can't be spinning the same direction because their south and north poles will line up and repel each other. But if one is spinning up and one is spinning down, then one south lines up with one north, and one north lines up with one south. And that helps them stay together despite them having the same charges. Hopefully this will help you remember a little bit about these quantum numbers. Please come back and watch this video whenever you need to, and ask me any questions if you have them.